x's do not repeat. X's cannot repeat. And now your y's will repeat. These graphs are very, very, very similar to the absolute value ones. Now, we spent a long time on those. We're not going to spend near the days. Well, I'd love to just spend this one day. We'll just kind of see how it goes. So I'm going to go over and do my heading, but I am going to flip back to the absolute value graphs. It was the first family of graphs that I teach by the transformations. So 74. Today's the 15th. Now, if you're graphing linear functions, the easiest way to graph them is y equals mx plus b. You know, do the slope, find the y-intercept, rise and run, and do that. These are quadratic functions. Now, this is also called, let's see, I think I just said graph quadratic functions, but we're going to actually graph them in what we call vertex form. Now, vertex form is not going to look like, let me write this for you. Standard form is y equals ax squared plus bx plus c. We've replaced the 0 with y. We've made them ordered pairs, and a can't be 0. We will do those, hopefully we can do them till Wednesday. That's standard form. Vertex form is very, very, very almost identical. By the way, remember y can be f of x, and vertex form is y equals, or f of x equals, a times x minus h quantity squared plus k. Now, I hope that sounds familiar to you. Let me pull the other classes notebook. That way I won't have to flip back and forth. Let me see if I can find what I'm looking for. Here we go. Mm-hmm. Because most of your upper math classes emphasize it as a function, and it's just a different notation, is all it is. We actually did it, let me show you here. When we did back in November, we did absolute value functions. We spent a page on what functions were, and then we started talking about the parent, and we did write it f of x. Okay, are you watching? F of x, and we talked about that being the parent. We graphed it, and it was a V. Now, I want you to look at this right here, and I want you to look at what we just wrote, and they're hard to put side by side here. Let me see if I can do it this way. We wrote this upside down, backward, forward, whatever. We did our form of a, let me go up just a little bit, see if I can do it. I don't think it's going to happen. Maybe. When we were doing these, we put them in this form of a times x minus h in absolute value plus k. That was our v's. Look at the difference. And we wrote y, you can do f of x there. Look, a, x minus h, this time we're doing squared. Remember, to be quadratic, it has to have a squared in it. And then the plus k. So all of this that we did down here is going to tie into, you got everything you need? You're okay? That's okay. Oh, I see. That's okay. You're fine. Just want to get everybody situated. And then the vertex form. So what we're interested in on these, and let me get situated here, is do a little bit of review from that. And the vertex, I tell you what, I'm going to skip a little bit of room here, and I'm going to talk about the parent. Let's see how many lines you need. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'll do an extra one. I'm sorry. There you go. And I've moved that camera, and I don't remember that I've moved it, so I have to be very careful with it, or move my iPad. Okay, so we are going to talk about the parent, and then we're going to come up here and start talking about the stuff we're going to do with it. And the parent is f of x, or y equals x squared. That's the basic one. And our t-table is going to be x, y. You can do y again. You can do f of x there. And we're going to do from -3 to +3. And I hope I'm on screen. Yeah, there we are. Now, you only need a ruler to draw the axes because you can't draw the graph with a ruler. Like these, we would use a ruler. You can only use your ruler to draw your straight edge, whatever you're using, to draw the axes. Now, I want to be on the, you know, when I open it, it's got the big grid. When it's closed, it's got little grid. I want the little grid up, and we're going to end up gluing it over here. But I want us to draw an X and a Y. You can put it kind of in the center. Okay, what's the matter? Okay, no, look at me. We're going to do it just like we did back in November. It's like this. We're going to open it like this in a few minutes, and we're going to graph in here. If you want to write glue, you're going to glue it back here. I usually put an X where I'm going to glue it. So we're going to do the parent here. We're going to put probably 3 graphs in here. Okay, and then we'll glue this on page 75. Now, I'm going to have to kind of, let me see if I can zoom out any more. I think, I don't think it will let me go any further. So I'm going to have to just kind of play with it here. Now, the arithmetic's a little more involved than absolute value. You're just squaring the numbers, but I think you can do that all the way down. We're trying to get shortcuts so we don't have to square it. So we don't have to do all the arithmetic. So when you put -3 in for x, then, because what we're saying here, Colby, here's a good way to write it. You can say f of -3 equals -3 squared, and then we know that's equal to 9. So that's why we like that notation better. But we don't have to go all the way across on that. You can write it down if you want to. I'm putting it on the video. But we can just square it. What's -2 squared? -2 times -2. 4. +4, -1 squared. 1, 0, 1, 2, 2 squared is 4, 3 squared is 9. If we do 4, it's 16. We don't have enough spaces to do 16, so we're only going to do those. Now, we're going to plot these. Okay, and I'm going to have to just slide mine. Let's see if I can go this way. But then I don't think you can see all of my graph. I think I'm going to have to slide my table a little bit further. Let's see if it'll let me do it. And I'm just going to plot these. I'm going to remember this is your x-axis, this is your y-axis. So it's easier for you to count. Count -3 and then go to +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then go to -2 and go to +4. And again, if you'll count them on your paper, it's either trying to copy them off of here. -1, 1, 0, 0, 1, 1, 2, 4. Now, do you see the symmetry? See how those are in the same places? And then 3 will actually be up here because this was 9 up. It's going to be 9 up, which would be right there. If you try to line them up with a ruler, they're not aligned. This is a curve. When we get a chance, we just don't have time to do it today, we will graph them on a calculator and you get a feel for what they're doing. They don't bow back in. You're looking at me? Because if they come back in, you repeat X's. They don't trumpet out. They're like the St. Louis Arch. Of course, it's going the other way. We'll address that here today or Wednesday. But it's actually just getting a little wider and a little wider. Like your V went like this, it's going to actually do this. Now, this is the best way to connect them. go to this point, which if you remember from the absolute value was vertex. And I usually just start here and I just kind of start sketching. And I'm just let me kind of show you. It's a curve, very St. Louis arch. And you want to take it all the way up a little bit higher with a arrow on the end of it. It does not curve back in. It doesn't quickly go out like a trumpet. It's just going to get wider and wider. And then just do the same thing over here. Now the hardest part about drawing these is you're only going to get 3 points if you do the shortcut. Now some of you, when we did absolute value, did extra, but I told you then you won't get extras when you do the squareds. This is y equals, or f of x equals x squared. It is the parent, and the name of this curve is a parabola. Okay. I've heard people say parabola, but it's parabola is how you pronounce it. Okay. Now, if you remember from absolute value, and again, I can't get all that on the screen, there's things we're going to be interested in. This is the vertex. Okay. So, from back in November, the vertex is going to be H, comma, K. Am I on screen? Here we go. Okay, now draw you an arrow and write opposite, and draw you an arrow and write same. Okay, positive A, this number right here, opens up, and negative A opens down. And then if you remember, that number is going to help us do the stretch exactly like we did in lesson. I tell you what, I'm going to actually, to get those rules, it was back in November, I'm going to actually put the page numbers so you can refer back to them. For some reason, here we go. Some of that is missing, and I may have had to do it in somebody else's notebook. So I'm going to say, make sure I'm in the right one. Yeah, it's lesson 26, C, lesson 26, pages, and I think we did it on 4 pages. I think it was pages 60, 61, 62, 63. So if you'll write that at the top of page 32, that's going to help you with some of this stuff. Which way? So you can see the T-table. Has everybody got this part? Okay, let me go up for the T-table. Got it? Okay. So on this one, on the parent, the vertex is 0, 0. It opens up because you notice A was 1. See, A was 1 in front of x squared. It opened up, A was 1, and it's called standard size.